Okay, let me start the session. Is everyone ready? Good. So the last week we covered there was a special lecture, Sarok, and she described what she did on industrial changes using simulation dynamics model, which is bit, as I explained, which is a little different approach compared to the optimization like PIPESA. Because in case of PIPESA, we put all the restrictions and like constraint and cost objective functions, and then try to find, in case of cost objective, try to find the minimal cost or the maximum cost within the restrictions that we provided. That's what happens in optimization process. When we say optimization process here, it means linear programming or mixed integer linear programming, basically linear programming. And there are other types of optimization programming, optimization algorithm, but this is the most common one. And then, in case of simulation dynamics, it's a series of equations that the program computer is going to solve. So usually simulation dynamics is much faster than optimization process. For example, I can share one of my screen that I'm working on at the moment. So this is the process that I'm working on. So it's about shipping, decarbonization of a shipping industry in South Korea. And there are about 300 different scenarios. And I started to run this optimization process around the 9 p.m. yesterday, and it is still doing about 90%, about 99% though, but it takes lots of time sometimes. However, in case of simulation dynamics, it's much faster. So if you want to make your own code web-based, probably simulation dynamics could be a better option. But the result is always a bit different, depending on what kind of optimization process, what kind of algorithm you choose. Even between optimization algorithms, there are different approaches, and then they all provide different results. They not always exactly opposite, but more likely almost the same, but slightly off to each other based on how to optimize it. So that's more technical term. And last week we covered some other part, like where to download the data, right? We have IEA database and we have Ember database as well, and World Bank. And then also we have a Copernicus climate data, which is mostly satellite data set. And we have data like Renewable Ninja. And but there is another couple of more data sets that I didn't mention. I think one is IRENA is a great data source where you can have a look. So IRENA, International Renewable Energy, I don't know, something Alliance or something. Can't remember their full name. Always I just call them IRENA or IRENA. So they do have a statistical data set and some quite useful information as well. And then there is a GEM, which is Global Energy Monitor. They also provide a really nice data set. And definitely, we provide small amount of data on our GitHub, but our data, what we provide is not particularly about data, but it's more about model. So I hope that we can have opportunity to explain or um, let you know how to use these open source models that we developed. What we would like to do today for the next 2 hours is going to be import model from CSV, and then we are going to run the model directly from CSV. So not really directly on CSV, but we are going to import the model from CSV, and we are not going to change it, but we are going to just run it to see if it actually works and if it makes your life much easier. And yes, that will make your life much easier. So after this part, you will be able to build a simplified real-world model using CSV template that I provide the CSV template, right? And then we are going to tweak around in the CSV file rather than in the pipes code. So what we need to understand first is importing from CSV folder. This is one of the method that pipes are provide. So it's quite simple. As far as you just type import from CSV folder, and then as far as you have all CSV files in a proper structure, then PIPESA will not have any trouble in load them, in import them to the network and then build the network in just one click. Okay. So before we go for that stage, we need to download our data set. So you can go to our Google Drive. For those who forgot the link, I sent a link on our Google Meet message, on our message. So have a look at it and click it. And you can download all the data set like this, or you can just choose one of the country you have interest in. Okay, but before we start, let's have a small survey. Okay, if I wonder how many of you are from Indonesia. Can you just thumb up if you are from Indonesia or you are going to use the Indonesian data set? So just Abraham, only one person. Paulo, yes, I expected two. And then what about India? We have three so far. What about India? Do we have how many people? We don't have any. Yeah, I think there was one Indian person in the beginning, but probably he left. Then Japan. There was one person working in Japan, but not Japanese. I think probably Alvin, but probably he's not here as well. So we don't have Japan. Actually, it's fine. And what about Korea? How many? So at least we have three, four, probably four, five people. And the Philippines, Amanda, thank you. Charles, thank you. And the last, Pakistan. How many? I think there are a few Pakistans here, Pakistanis, right? At least we have three. That's perfectly enough. So yeah, during this course, please open the this Google file together with you, Google slide together with you. Not the week 6, but week 7. Then you will be able to see the country code, and each of you will fill the value here. So if you find the same value, it's fine. You can just type it once again. I mean, when one person type with enter number, and if you have the same number as a result, it's fine. You can just enter it once again. And if you think your value is different or your result is different, still fine. Just type it again, and then we will validate it during the last week, and then we will see how to analyze and how to make it as a very simple report. Okay. But before that, let's go to week 6 that we were not able to do because of my mistake. And I found the reason that yeah, actually a couple of weeks ago, about 2 weeks, no, about 2 weeks ago, I wanted to delete the files from download directory, but by mistake, I deleted the files from recent. So yeah, I lost lots of files since then, but I recovered most of them, fortunately. So yeah, please download the file here and then put them in your directory. And its structure is going to be something like this. In my case, I have all my working Google notebook here. I'm sorry, Jupyter notebooks here. And then I have data folder. And then in there, I have demand and some other folders, but demand data, I don't think demand data is really important. I don't think we are going to use it anyway, but this is the structure that I had, right? Okay, let's create a notebook. And then we will import pipes. Sorry, this must be too small. Big enough, right? Then we are going to create pipes network. This is just a pretty much like very basic thing that you always need to do. And then now we have something new. Let's run it. Let's make sure that we import all the pipes library and everything. Let's wait until it's done. Yep. Is it still? Seems it takes a little longer. Yep. Now I have it. And then now we are going to import network import from CSV folder, and it is in data folder. And this time I'm going to import Japan and run it. Sorry, there must be something wrong. File not found error. Blah blah blah. Let me see if I have the file properly. Yes, I do have the file and everything. What is going on? Okay, Charles.
Yeah, I think because your notebook is inside the data folder.
Thank you. Let me just recreate it. I made it in a wrong place. Thank you so much. Import pipes again. And then define the network. And then import from CSV from folder. I don't think this is going to be the best way of making the name of a method, but this is how it is. Thank you so much, Charles. I owe you a coffee. I visit the Philippines. Why do I have the same problem here? Give me one second. Import from.
Sangin.
Mhm.
You're setting the network to be import from CSV folder. You're using the equal sign instead of the period.
Ah,
That's two coffees, right?
two coffees.
Just kidding.
Yeah, two coffees, no problem. Ah, thank you so much. And there is a question from Abraham. I have this warning when I run it. Warning pipes IO importing network from pipes version V, while current version is V 0.3. Yeah, so far it's fine. Usually warnings are usually fine as far as it works, right? When there is a different version on when some method is going to be deprecated, then you will see warning. But as far as it's not error, usually it's fine. And I have the same issue here, right? So means I need to update the pipes, I guess, but it's fine. And then we will see the structure. We already have one bus and 3 carriers and 8 generators and 1 load. Fantastic. But can we really trust this to make sure that we want to go back to our data. I imported this Japan data from Japan, but the structure is exactly the same, only the numbers are different. So you can just see your own country's data. Okay, let's double check the data from bus. It's pretty simple, right? We have just one bus. This is the structure that this bus CSV file must have. So the name of this CSV file must be buses, and then it must have name and bus, um, name of the bus, and then you can add some others like Venom or others like carriers and etc. etc. By column. And then if you have multiple buses, you can add something like bus one, bus two, bus three, or something like that. So by row. Okay. But we have only one bus, which means this is just a single node, single node approach. So we are not going to worry too much about geographical issues or transmission issues. Basically, I wouldn't say too much, but we are not going to treat transmission as a problem at all in this task, right? What we are going to focus on is temporal changes or generation mix itself. And let's check the carrier file. We have carrier CSVs, and then we have three different carriers. One, fossil fuel, and we have nuclear, and we have renewable. And each has its own color, gray, blue, and green. Right? And then jump into the generators file, which is the most interesting one. You guys are all following, right? Am I doing too fast? Okay, as far as no one says it's too fast, I think it should be fine. Let me know if it's too fast. So in case of a generator, I got this data from two different sources. In case of capacity, I downloaded this data from Ember. And then in case of CO2 intensity, it's basically from my brain. So not really a reliable source at all. And in case of efficiency and marginal cost and the capital cost, I downloaded this data from PIPESA meteors. So there is a PIPESA, there are multiple PIPESA related projects. Recently, Trench and Zero also released their own PIPESA dashboard. And then, but PIPESA Earth is pretty well known modeling, PIPESA modeling framework, which covers the entire Earth. So that's PIPESA Earth, and they don't technically provide the data, but they provide a way to download data from known website. So I use the PIPESA Earth framework to get this data, so which include efficiency and marginal cost and then capital cost. Very simple, right? No, nothing like a ramp limit or mean up time or etc. If you want to add, you can just p norm, p min pu and say 0 0.5, 0 0.6, 0 0.5 or something like that. You can add it easy. And then let's go back and then let's see the load.csv. So as you can see, we have a load which is named load, and then that is connected to bus. And there are three more that we need to have a look. First, we have a snapshot. Interesting, right? I'm not going to explain you what waiting means, so just forget about it. But snapshots basically cover the entire time period that we want to model. So it starts from January the 1st in 2024 until 31st of December in 2024. There are different ways. I mean, for sure, you can set the data as a date and time as day, month, and year, or year, month, day, year, month, date, year, whatever you like. But to the best of my knowledge, the default of PIPSA is usually month, date, year, which annoys me a lot. I prefer just ordered one, year, month, day, or day, month, year. That's much easier. I don't know what happened to this, to English, but this is snapshot. And very important, we have load. We load pset, right? Load pset means in the technically when we define the load, we need to define pset as well. Pset is the amount of a electricity demand, but we didn't define it here in the load file, but we defined in a separate file, which is loads dash p underscore set. And we have exactly the same snapshot, and we have hourly electricity demand. In this case, this is hourly electricity demand of Japan. Okay. And we have generators. Okay, Charles?
Yes, and then could you let me know what unit this is, the load?
It's usually it's called megawatt, but technically it's unitless. If you assume it is watt, then you can just use it watt everywhere. If you want to use it as megawatt, you need to use it as megawatt everywhere.
Got it. Thank you.
No problem. But usually just assume it as megawatt, because that's what most of people assume. And that's what actually PIPSA says, it's megawatt, but it is not. I mean, even if you assume it as gigawatt, still model works totally fine, no problem, and the result is going to be based on gigawatt, based on your calculation. So I think it's more likely just unitless. So now we have a Pmax PU, generators Pmax PU. Interesting point is, in this case, I defined it as a Pmax PU, but if you want to define it as pset, same like you can just change the file name, generators dash p underscore set .csv, then it becomes pset. So you need to follow the rule of basically you need to follow every single rule on how to structure the file inside and then how to name the files. As far as you have correct names and as far as you have correct structure, it's all fine. If you don't understand how to structure it, just make a very simple network and then export the network to Excel or CSVs. Then you will see the structure, right? Then you can use it as your own template to build your own model. So now what we are going to do is we have the network, right? So what do we need to do? We are going to run it. Let's see if there's any issue with the data set. We have three constraints and we have one continuous variable and it is working, no problem. And now returned with optimal. We have a proper result. It says okay, optimal. So means this is solved. Now let's have a look at the information data, how the pattern of this data set. Okay, I'm going to share this part of code on the chatting very soon. T.p, and then we are going to see only for the first 20 days, no, 10 days. Plot, we can plot it, but what kind of plot you would like to see it as area chart, and then it needs to be stacked, right? And figure size is not really important, but let's just define it just in case. Figure size is, I want to make the figure a little bit like longer, long width rather than too high. And I think that's it. And if we run it, we will have this chart. I'm going to share this code on the message, so you don't need to type this long code on your own. You can just copy and paste it. Do you have a similar output? Probably the output will be different by country. How is it going? So far, so good. Okay, seems the Philippines and Korea data is fine, and Pakistan is fine. And anyone from Indonesia? Thank you. So all the data is working totally fine. So now we have hourly electricity generation mix. Hourly generation mix. So at the bottom we have bioenergy, and we have coal power, and also we have hydropower, which becomes intermediate, and then also we have nuclear. I'm pretty sure nuclear is going to be more likely base load, but it's because of the order. It looks like intermediate. And then we have solar power, and then we have a little bit of wind somewhere. I think, yes, on the top, small amount of wind, because in Japan, if we see the capacity of Japan, network generators. If we see the generators information, basically, Japan doesn't have much wind, only about 5.8 gigawatt. But in case of solar, it has 91 gigawatt of solar. That's huge. That's big. So that's why we have lots of solar, but we don't have much wind here. So it's basically validated. Then we can see the price. We can see the S&P, so marginal price. How network, where does the marginal price is saved? Is under buses underscore T. And then you can just type marginal price. It's not marginal cost, but marginal price. You can type it, but I want to see it as chart. And then same here, bigger size is going to be 12 and 6. Since 6 is too, how can I say, too high on my screen, too poor. So let's make it 12 and 4. So that looks better. So we have marginal price changes over time. The lowest is going to be 0. So I'm pretty sure, can't pretty sure, but basically wind, solar, and hydro provide 100% of electricity. Then there is no marginal price, because I put 0 marginal price for wind, solar, and hydro, but all the other nuclear, coal, and gas, bio has their own marginal price, right? So that when it's 0, it means we only have renewables. And there are some places where the price like spiked up to 22, I think. Yeah, that's how it looks like. And then we can also double check the CO2 intensity. Let's get the CO2 data, network generators. Again, CO2 data is not default data set or default input and output data in of a pipeline. So we need to get it out of it from our own calculation. But fortunately, if you remember, I already put where is it? in the generator tab, in the generator's data CSV, we have CO2 intensity, right? It's not, again, this CO2 intensity is basically from my brain, so it's not correct number. But bioenergy is 0.7 and core is 0.9, gas and other fossil is 0.5, and the others is basically 0. So it's not going to be too wrong. And so let's go back. Let's get the number. And in case we had NAs, right? NAs must be 0. And then we want to see emissions hourly. How network generators T and its power. So basically, we want to get temporal information, temporal output of generator, and what data we want to get? We want to get P. P is a power. It's basically hourly. It's not technically hourly, but power output of every moment or every time snapshot that you defined. So in this case, it is going to be hourly electricity output, and we'll multiply it with the CO2, and x is 1, so CO2 by fuel. Now we can see emissions hourly. If we just type it, emission hourly, I missed S. So we have hourly emissions of the bus that we created. Sometimes it goes minus 0.0, but ignore it. It's just roundup error in the calculation usually, so it's not a problem. But what we want to see is axis, sum of all the numbers, and then sum it again. So the annual emission, and then divide it by network generators underscore T, the power, and here again, sum and sum, which means we would like to get the entire annual electricity demand, right? And then if we type it, basically the emission of this system is going to be 0.29 ton per megawatt hour, I think. Yeah, ton per 0.29 is basically is the output of the system. Okay, so far so good. It's all following. Are you guys doing on your own computer? Is it too fast? It's okay. I will wait here maybe about 10 seconds, just in case if there are people still typing or still not following. And if you have any question, please let me know. No problem. No problem, Bara. It's all up to you. Anyway, having some interaction is a good opportunity that you see even your trainer make mistake, and also it's a good opportunity to interact, right? And we would like to add a energy storage ESS. Definitely we can add it using our CSV, but we want to try to add it in using the code, just to make sure if we can actually add it on the code rather than just import entire from the CSV. So let's try to add network add. We are going to add a storage unit, right? And I will call it battery behind the meter. And it is going to be connected to bus. And each capacity, you can just decide the capacity whatever you would like to. No problem. After this course, after the first half of today's session, during the second session, basically we are going to do the process once again using each country's data, but to get different numbers to fill the report, to fill the slide of week 7. So still, it's okay. You can just follow. We have you can have different pnom, but I'm going to use 5,000. So 5 gigawatt in Japan, and is max hours is gonna be 4, so it can generate up to 4 hours. And then marginal cost, I'm not gonna set marginal just in case. Marginal cost is going to be 0, and then efficiency store is going to 0.95, and efficiency discharge is going to 0.95 as well. And then interesting point that we want to add, state or charge initial is gonna be 0.5, which means in the beginning this battery has 50% charged state status, and then cyclic state or charge is true, which means basically these batteries and the status must be 50% charged, right? And thank you, Amanda. Cyclic. This must be correct. I think no error. Yes, we added a battery now. If we review our network, then we have a bus carrier generator load, and we have additional storage unit, right? Network, my as we have more component, it takes more time to get the result. All we need to do is just waiting. We had 3 constraints before, but now we have 10 constraints, right? We had only 1 variable before, but now we have 4 variables due to adding just 1 more storage unit, which makes the entire process much slower. At the same time, it makes things a bit more vulnerable, which means vulnerable here means there is more chance that you get infeasibility, mathematically not solvable. And I already made a copied some part from the before last week chart, last week code, which I'm going to share on the slide for slide week 6. So add some battery here. Probably this is going to be the best place. So on week 6, page 17, I added short code so that you can just copy and paste. The reason that I just let you copy and paste is because it's all about plotting rather than actually analyzing or whatever. So then was to be 4, and we will see only 240 hours. And then if we run it, there's no output here. It's coming. Yes. So let's compare this. Where did you go? It's the subject. So let me copy. I think copy this to clipboard, and then let's try to compare this with the new output. Copy this to clipboard, and then Let's see. We have two different output here, right? Size is slightly different due to my mistake. However, still you can compare it. Let's just extend it a little. Okay. Can you see difference? Because 5 gigawatt is not really big in terms of the capacity compared to the entire demand of Japan. So maybe it's not very noticeable, but still we can see some changes. Like in case of, as we have a battery, there is negative generation, which means battery charging. So there is a bit of battery charge. And then there must be some battery discharge as well, which is yellow on the top. Yellow part on the top, right? It's a greenish yellow, I think, green yellow somewhere. Yeah. So we have a battery so that we might have slightly less fossil fuels, maybe. Yes, as if we compare here and here, I see slightly smaller amount of a other fossils, which is expensive. So this is how the things can be changed by adding a little bit amount of battery. So this might have different marginal price as well. So we can have a look at the marginal price as well. Let's just see. Not the emission, but just the marginal price. Come on. Why is not click? So we have network and marginal price is in buses T and marginal price. Show me the marginal price, please. Yes, we do have the marginal price, right? Seems like it's almost 0.4 almost always, but let's double check it if it's actually 0.4 or something else. Figure size is 12 and 4. It's possible because maybe in case of Indonesia, battery might not really useful. So it's totally understandable that sometimes some places battery really doesn't affect much. But it is also depends on what snapshots that you are looking at. Maybe it's because the snapshots that we chose to analyze is the first 10 days. That's what did not really make any difference. But if we see the marginal cost, this compared to the previous one here, do we have any difference? Yeah, I can see the difference. Interesting. Let's copy this output on top of this. And then let's copy the second output here in the template. See? So the top one is from the old code, which doesn't have any battery. The below one has a little more battery. So as we can see, we have still less time where the marginal price spiked, right? We have more time where marginal price can be much lower than before. So slight difference, but not huge difference, but slightly battery made some changes in Japan. Okay. Thank you so far, and let's have a break for 10 minutes, and then we'll come back here on time, and we will go through the next half.